Force and pressure. Activity. Newton meter. Objective. To make a spring balance. Theory. The spring balance is simply a spring fixed at one end with a hook to attach an object at the other end. It works by Hooke's law, which states that the force needed to extend a spring is proportional to the distance that spring is extended from its rest position. Therefore, the scale markings on the spring scale are equally spaced. Spring balance is a weighing scale, consisting of a pan suspended below a vertical spiral spring, used to measure the weight. When a specimen is placed on the pan, the spring stretches along a calibrated scale and a pointer indicates the weight. Did you know? 1. Spring scales come in different sizes. Generally, small scales that measure newtons will have a less firm spring, one with a smaller spring constant, than larger ones that measure tens, hundreds or thousands of newtons. 2. Spring scales can be used in physics and education as basic accelerometers, but its main uses are industrial, especially related to weighing heavy loads such as trucks, storage silos, and material carried on a conveyor belt. Learning outcomes. Students will be able to 1. Understand the calibration of a spring balance. 2. Measure weights of different objects using spring balance. Materials required. 1. A spring. 2. Paper clips. 3. Small plastic bucket or a paper or plastic cup with string tied through holes near the top to form a handle. 4. Objects to use as weights, such as coins. 5. Weighing machine. 6. Ruler. 7. Paper and pencil or pen. 8. Various small household objects to measure. Procedure. 1. Hang the spring vertically from one of the paper clips by hooking the coil of the spring with one end of the paper clip. 2. Use the ruler to measure the length of the spring with no weight hanging from it. Write this number down. 3. Now, use a second paper clip, looped onto the bottom coil of the spring, to hang the bucket or cup from the bottom of the spring. 4. Add a few weights, such as coins, to the bucket or cup. Add enough weight that the spring stretches out a bit and you can measure a change in length. 5. Measure the new length of the spring and write this number down. 6. Remove the bucket or cup from the spring and weigh it, including the weights, using the weighing machine. Write this number down next to the distance you just measured. 7. Repeat this process and add a few more weights to the bucket or cup. Write down the new length of the spring and the new weight. 8. Now hang the object you want to weigh on the spring balance and measure how far the spring stretches. Also, look at the corresponding weight. 9. Repeat this process with a few more objects and measure their weight using your spring scale. Observation. Conclusion. The extension in the spring is directly proportional to the weight attached to it. This property helps in measuring the weight of objects using spring balance. Sorting queries.
I am a little confused. When we hang an object on the spring balance, its spring stretches, then how does it moves back to its original position on removing the object?
On removing the object, spring moves back due to its elasticity. Elasticity is the ability of a deformed material body to return to its original shape and size when the forces causing the deformation are removed.
It means we can keep on adding the weights and every time the spring will move back due to its elasticity?
No, it is not so. There is a maximum limit of weight up to which the spring can show its elastic properties. On increasing the weight beyond this limit, the spring will be permanently deformed. This elastic limit of a spring decides the range of spring balance. Case study: Anti-gravity hills. There is a mysterious place in Gujarat known as Tulsi Shyam where gravity does not work. The phenomenon of witnessing your vehicle creeping uphill at a speed of 20 km per hour even though you set it to neutral at the base of the hill is a reality. The Electric Bay in South Ayrshire, Scotland, the Gravity Hill in Prosser, Washington, the Confusion Hill in Pierce, California, and the Magnetic Hill in Black Rock, Australia, are also similar places located in different parts of the world. Can you find out the reason for the anomalous behavior of such places? We hope you liked this activity. Happy learning!